Here I'm going to go through a Leaving Cert past paper question. It came up in 2018. It's paper 1, question 6. And it has to do with functions, graphs of functions. You are asked to find the coordinates of the points of intersection. So we can see that there's 3 points of intersection there of the graphs of 2 functions. Now, one function is h of x equal to x, and the other one is k of x equal to x cubed. So, to find any point of intersection, both of those functions are equal to y. Okay, so h of x is another term for y, k of x is another term for y. So if they're both equal to y, we let them equal to each other to solve. H of x equals x, k of x equals x cubed, x equals x cubed. Then if we're trying to factorize something like that, x cubed minus x equals 0. X outside of x squared minus 1 equals 0. So therefore, we know that x squared minus 1 is just the difference of 2 squares. So if we want to factorize that, we've got x outside of x plus 1, x minus 1 equals 0. So if they're the factors, the roots are x equal to 0, x equals to minus 1, x equals to plus 1. We just need to work out the corresponding y values then. Y equals 0, y equals minus 1 cubed, which is minus 1, and y equals plus 1 cubed, which is 1. So our points are 0, 0, minus 1, and 1, 1. They are 3 points of intersection. You're then asked to find here the area enclosed by the graphs of the functions. So that area there and that area there. Well, the handy thing here is the symmetry involved. Okay, so basically if this is area 1 and this is area 2, we can see that due to the symmetry that we have there, the area 1 is equal to area 2. So actually all we need to do is work out one of those areas, let's say the yellow one, and we'll be able to double it to get the overall area enclosed by the 2 functions. You could do them separately and then add it together, but just a trick to do it this way. And when we're finding the area, we know that we take the function that's on top there, which is our linear, and we integrate it. Okay. Now if I integrated that function on top, I would get the area always between that line, okay, and this value here and this value here, between that line and the x-axis. If I integrated this function between these 2 values, so that's my cubic function between those 2 values, I would have, which is 1 and 0 from the first question, I would get the area there that I've put in dashed lines there. But to get the area in between the 2 functions, all we have to do is subtract the 2 functions and get the resulting integral of that. So area is equal to twice the area, because we're just doubling it, between 1 and 0 of x minus x cubed dx. That's going to be equal to twice x squared over 2 minus x to the power of 4 over 4 between 1 and 0. So that's going to be 2 outside of 1/2 minus 1/4 minus, well, just for the sake of it, plugging that in, 0. So we've got 1/2 minus 1/4, so that's 0.5 minus 0.25, which is 1/4, times 2, so that's 1/2, minus 0. So it's going to be, the answer there is just 1/2 for that. So that is the total area enclosed, okay, between those 2 functions. So that means the area of one of them is 1/4. But we're asked for the area of both, so that is 1/2. On the diagram on the previous page, using symmetry or otherwise, draw the graph of k to the minus 1, the inverse function of k. Okay, so we can use symmetry to work this out, but it's going to look essentially like the opposite of that. But that function is y is equal to x cubed. what we do to work out the inverse of the function there is we isolate x. So we take the cube root of both sides. So y to the power of 1/3 is equal to x. And now I'm just going to replace the y with x and the x with the y. So therefore x to the power of 1/3 is equal to y. So therefore for the inverse k minus 1 of x, it's just x to the power of 1/3. So using symmetry, we know that we can work it out, but if you want to plot a couple of points, all we need to do is we could say when x equals 0, y equals x to the power of 1/3 equals 0 to the power of 1/3, which is 0. When x equals 1, y equals 1 to the power of 1/3. 1 to the power of 1/3 is also 1. X equals minus 1, y is equal to minus 1 to the 1/3, which is minus 1. That's just the cubed root of minus 1. X equals to a half, y equals 1/2 to the power of 1/3. Just if you want to add for your symmetry's sake, just to try and draw it, y equals 0.8, x equals minus a half. This is just to try and plot the curve. Y equals minus a half to the power of 1/3, which is minus 0.8. We can put a couple of those points in to this function just to show you, we want to plot a few points. For this function we had when x was minus 1, y was minus 1. When x was 0, y was 0. So all these points are on the function. When x is equal to a half, or minus a half, y was equal to minus 0.8, which is there. And when x is equal to a half, y was equal to 0.8, which is around here. So if you want to then sketch that, the curve goes this way up like that. So that is the inverse of k of x. There. So we only got an extra couple of points there just to show you how to draw it, but of course using symmetry we know that it's going to be the opposite or the inverse to the original function.